Doc Revis here with Watch Me Work It, predicting products from uncommon non-metal combinations. Let's start with one that's not so uncommon. Let's start with carbon and nitrogen. What compound might you expect from a combination of carbon and nitrogen? Well, since carbon's on the left side, it will have the plus charge, electropositive, and nitrogen on the left, it will have the minus charge based on position on the periodic table. How do we know what the charge will be? Let's count and see. For the positive, we count from the left to right, and this will be 1, 2, 3, 4. So we have carbon here with a +4, and nitrogen, we count from the left side. Don't count the noble gases. When we start counting fluorine, 1, 2, 3. So this will be a -3. So we crisscross these charges, and we get C3N4. Now, that's not so uncommon. Well, what happens if we look at the combination between oxygen and fluorine? Most like to assign automatically oxygen with a -2. Well, in this case, oxygen is on the left, and it will be the electropositive side. That shocks some because they've automatically memorized that oxygen should always be -2. But that's not always true. And here's a case where it won't be true. Oxygen's on the left, so it'll be positive. Fluorine's on the right, so it will be negative, and we'll count from the left to right to see what its oxidation state would be. Its charge would be 1, 2, 3, 4, 5, 6. Therefore, oxygen will be +6, and fluorine, one space back, will be -1. So if we crisscross these charges, we get a combination of oxygen with a 1 and fluorine with a 6, and we don't like to write 1, so we write OF6. In this case, again, oxygen would be +6 because it's the electropositive part of this combination. Let's take a look at another example, sulfur and oxygen. Sulfur's on the bottom, therefore it's more electropositive, and oxygen would be the negative. So in this case, we count for sulfur, and we count 1, 2, 3, 4, 5, 6. Oh, we have a +6 again here. So this is +6, and oxygen count backward for the negative, be -1, -2 here. So this is -2. We crisscross these charges, and we get S2O6, and we can reduce those to 1 and a 3, and we don't like to write 1, so we will write SO3, and that will be your combination. So remember, when counting positive charges, start from the left side of the periodic table, skip the transitions, and see where you land. To count negative, start at the right side of the periodic table, start at the noble gases, 0, and count backward to determine the negative charges. So there you have it, predicting products from uncommon non-metal combinations.